So, hello everyone, welcome to my YouTube channel. My name is Parthu. Today we're gonna discuss why bias is important in ANNs. Most people think that neural network only learn by weights, but there is another small term that completely changes what network can represent. That term is called bias. Today I'll show you why bias is not just an extra term. So, let's start with this. So, for example, this is our ANN. We have two input neurons, a hidden layer and an output layer, which includes only one output neuron. So in hidden layer we have four input of ANN nodes. So what exactly each neuron is doing? It's just computing W transpose X plus B. The W here is the weight matrix, X is the input vector, or W is the weight vector, X is the input vector, and B is the bias. So today we'll understand what is this term is doing, what bias is doing here. So now if you remove the bias, then let's see what it computes. What a neuron is computing. It's just computing this term. WT W transpose X. So now if the X is 0, if the input is 0, no matter what the weight, it still the output will be 0. Mathematically speaking, it will be f of 0 will be 0. So what does this represent? If a equation equals to 0, it satisfies with 0, then it means it's passing through the origin. So here, if you add the bias, there the shift happens. So I can show you this thing into the Desmos. So for example, here I am using just an equation like y equal to 7x. So you can see the line, it is passing through the origin. So if I add another term, like for example this the same equation, I'm just adding plus 9, a bias here. Let's see what happens. So if I add it, you can see the orientation is the same, the orientation of the line is same, but there is a shift happened. You can clearly see that shift. So bias is doing what? Bias is responsible for the shift happening in the 2D plot. So you can understand it without bias. So without bias, what will be happening? So what bias is doing here? Bias is responsible for the shift happening in the decision boundary here. So you can, I'll show you with it an example. I'll show you with an example. So let's say we are taking two example, class 1 and class 0. We want to classify them. So class 0 consists of 2 points, 1 1, and class 1 is consist of 4 5. So the weight here is 1 comma 1, and the neuron computes this thing. So here we are having like two classes, so two inputs, that's why x1 and x2, and two weights, w1 w2, and b the bias term. It's the standard case. First we'll compute it without the bias. So without the bias it will be 2 and 9, both are positive. So if you want to classify, if our classifier is designed in a such way that if the output is greater than 0, then it will be 1, or if it is less than 0, then it will be 0. So in this particular example, if we remove the bias, we cannot classify the 2 points because it's both are positive and both becomes class 1. We cannot separate them. But if we take bias, let's say we take bias as -5. So here you can clearly see one is -3 and one is 4, positive 4. Now we can classify the both points. So what exactly bias is doing? Why bias is responsible for the shift happening in the decision boundary? So why it matters in machine learning or in ANNs, why the biases matter? Because the real world data is not centered at the origin. If all boundaries passes through origin, the model cannot separate many dataset properly. So by adding bias, it removes the structural restrictions, and So without bias, what was happening? Without bias, the transformation was purely linear. And if you add the bias, when you add the bias, the transformation becomes affine. And when you are using with no bias, I mean zero bias or without bias, the model must preserve the origin. The decision boundary will always be passing through the origin. And if you add the bias, the model can shift the decision boundary. So let's summarize this. Without bias, the decision boundary must pass through the origin. The model is quite a bit restricted. And with bias, the decision boundary can shift, the model becomes expressive, and the hypothesis space increase. So what weight is doing here? Weight is responsible for the orientation, and bias controls the shift or the position. So, and that's why bias is essential in neural network. And well, this was it. And in another video, we'll see the implementation of it. We will see that what happened using when we are using the bias, and when we are using no bias. So thanks for watching.